Hi everyone, welcome to this episode of Keipert Labs. In this video today we're going to be making the case for continental drift. So thinking about the idea of where the continents are today and thinking about how that may have been different in the past, and then going through some of the scientific evidence that suggests that this is something that may be the case. Okay, but so the first thing that we're going to do is we're going to take a little, do a little geography activity. Okay, so you have a copy of these same sheets which show you the continents as we know them now. Okay, so hopefully you know what these are. If you don't, study a little harder in geography, please. Okay, so this is Africa. We've got South America. We've got Oceania, as far as, you know, seeing part of Australia and Indonesia up there. We've got India. And then, actually, if I just bump these up a little bit, we've got Antarctica. Okay, now, you know, these aren't exactly, you know, to scale, let's be honest. However, you know, it's just so you can kind of see them on the screen at the same time. That's probably a bit more like that, but anyway. Okay, so this is kind of roughly the position of where the continents are today. But as you've already looked at, this man named Alfred Wegener, an amateur meteorologist from Germany, had a bit of a look at these on a map. And what you can see here is we've color-coded some of the different fossils that were found on each of these different continents. And what he recognized is where the continents are today is perhaps not exactly where they have been for the history of the Earth. Okay, at the time that he was proposing this idea, that it was the first time that scientists had given serious thought to the fact that the Earth may be a lot older than people previously thought. And then he proposed this idea that actually the continents have moved, because what he noticed was that the shape of South America and the shape of Africa seem like they connect together rather well, and like making a jigsaw puzzle. Now, I realise that we're not showing all the continents here, but we're showing kind of a selection of different continents. And then what you notice, aside from the physical fit here, is that these coloured bands of fossils start to line up into a more of a continuous line. You know, so this red kind of band here, which was kind of a prehistoric kind of crocodile type creature, and then this green one, which was Glossopteris, a prehistoric fern, and then some other kind of animal fossils, and then following kind of the same lines, then recognizing that some other kind of parts seem to fit together rather well as well. So kind of looking at, you know, if we kind of play jigsaw a little bit, then we can kind of make them fit fairly well. And perhaps if I rotate them around a little bit so you can see them a bit better on the screen, that now that we've taken these continents that these days are very separate and have oceans between them, that then actually, if we use a bit of imagination and a little bit of our fine motor skills to cut them out, that we can see that they fit together rather well, you know, with a little bit of wiggle room, of course. And that our fossil bands actually seem to run all the way through. This green Glossopteris band in particular extends over each of these 5 continents. Okay, and then this other kind of grey-blue band over here as well across 3 different continents. Okay, and so Alfred Wegener then proposed this idea, which was deemed to be silly at the time, that this suggested that the continents actually used to be together once upon a time, a long time ago in history, in the Earth's history. And so he called this idea continental drift. That it seemed very strange to people at the time. It took a very long time for his ideas to be accepted, sadly after his death. But so now it's become much more of an established scientific theory that with a lot more evidence to support it. So let's spend a bit of time now going through, aside from, you know, what you've just seen here, and you need to, you know, do your own version of this where you cut them out, you colour code them, and then you stick them in. Okay. Then let's go through some of the other items of evidence. Okay, so we've moved those out of the way. I'll just kind of mucked up my heading a little bit. Okay, so let's go through some of these items of evidence. Okay, so the first one that we would say, what we've just seen now, is this idea that the continents seem to fit together with using a bit of our jigsaw skills, that they seem to fit together. So thinking about Africa and South America. Their shapes seem to work rather well together. Okay, that is an A. Apologies for my average handwriting. Okay. The next thing that helps to give further weight to the fact that this fit may make more sense, is this idea that we have fossils across the continents. Okay, and especially if we're finding, say, like tropical plants in Antarctica. Okay, so suggesting that Antarctica may not have been as cold in the past as it is now. Okay, we're seeing this idea that it's not just plant fossils, it's not just one isolated fossil, but we're seeing a variety of plants and animals in fossils stretching across continents that are now very separate, suggesting that they may have been a lot closer together in the past. Okay, we also can see some similarity in present-day organisms on distant continents. So, seeing that there are some organisms alive today that we have the same type of organism on continents that are a very long way apart from each other, but suggesting in the past that they may have originally been a lot closer together before the continents became more separate. Now, not just in terms of our jigsaw fit, not just in terms of organisms that have died a long time ago, or organisms that are actually alive, but also in the abiotic kind of factors, that what we get is very similar rock layers, which we would call strata, okay, surrounding the fossils, on same thing on distant continents. As far as we're seeing different strata of rocks in Britain being similar to other places in Europe or in North America and all those sorts of things. And so that part of this idea is that rock layers get deposited down over time, and that the sequence that they get deposited in, it gives us a bit of an idea of the time scale. So that earlier rocks get deposited before later rocks, and so on. Okay, but the rock pattern forms a bit of a fingerprint, or this idea of a shared history of different, otherwise shared. I'm getting myself confused here. Shared history of otherwise distant continents that seem to have gone through the same sort of events in the past. Especially if thinking about volcanic rocks and things like that come about as a result of particular events. And then also a relation, related to this, is that certain rock layers, especially ones that actually, rock that comes out of the inside of the Earth, so where tectonic plates might be spreading apart and the rock that kind of comes up in the gap, some of that rock, which contains iron, is magnetic. Okay, and so what that does is that there are certain magnetic kind of iron particles that exist in the rocks that they tend to line up a certain way based on what things were like inside the Earth at the time. Okay, because the Earth is essentially a giant magnet inside, and so these rocks will align with the magnet inside the Earth, and this alignment, the magnetic behavior of the Earth has changed over time, and so what you get is these bands of kind of alignment. So maybe you get one band where all the magnets kind of line up like this. Magnetic particles, form these kind of patterns, and then maybe in a different place at a rock formed at a different time might line up like this, and then it might reverse at different points. And so what we're seeing is some similarity in the alignment of these magnetic particles in rock layers of very distant continents. Okay, so all of these items of evidence, one in isolation, a jigsaw fit of the continents might just be an exercise in imagination. Looking at distant fossils might be a curiosity, but when you look at each of these items of evidence together, so looking at each of these pieces, strongly suggests or helps to give a lot of weight to the scientific theory that these continents were once together at some point in the distant past, and that as a result of changes that have happened in the Earth, that they have moved apart from one another over time to where we are today. Okay, and we can also observe this a little more in our own timescale. We can see that continents are continuing to move apart from one another. It's very slow, but it's noticeable, especially when you consider the lifespan of your average human being, that these things can be measured across our lifespan as well. And so Alfred Wegener was eventually proved correct, or at least it's the most it's the best supported theory that we have at the moment. That's how science works. Okay, and so each of these provides evidence for his idea. All right, thanks very much for watching. Bye for now.